The subject of what existed before the enormous detonation has ignited interest and discussion for quite a while. It is a major secret, not just about how we could figure out the universe, but also about the constraints of human knowledge. Imagine standing on the edge of whatever is on thinking's mind. Was there anything before the universe began? The huge explosion marks the beginning of all that we know: time, space, and matter. But was there something before it? Could there have been a time before this staggering event? And if so, what was it like? As we explore this question, science takes us on a journey into ideas that challenge what we assume we know. Popular physicist Brian Cox, who is known for explaining the marvels of the universe, suggests that something astonishing could have existed before the huge explosion. He raises questions about reality and existence. In this discussion, we will break down the science and ideas that could help us understand what came before everything we know. We will look at theories about quantum changes, dark energy, and even the possibility of multiple universes. The answers might surprise you and could fundamentally change the way we understand our place in the universe. Let's dive into a world beyond imagination, where mysteries still puzzle scientists and sometimes leave them questioning everything. To understand what existed before the huge explosion, we first need to understand what the enormous detonation truly was. Scientists say the enormous detonation was the moment when the universe became incredibly hot and condensed rapidly, expanding and initiating the development of matter and energy. When we look at the stars and galaxies today, we see signs of that hot beginning as galaxies spread out from a starting point. But why did this happen? And was there anything before this hot beginning? According to the theory of cosmic inflation, before the enormous detonation, the universe was cold, empty, and void. However, this emptiness was not truly empty. It contained a lot of energy that caused the rapid expansion of space itself. This rapid expansion, called inflation, happened so quickly that it set the stage for everything that came afterward. When this expansion slowed down, the energy transformed into matter and the forces we recognize as the huge explosion. But where did this energy come from? And why did it suddenly create the universe? Some scientists believe that this inflation created patches of the universe, each with its own huge explosion, like a cosmic fabric stretching endlessly, with bubbles forming here and there, each bubble representing a different universe, including our own. This idea, called the inflationary multiverse, suggests that there could be an infinite number of Big Bangs and universes. Our universe is just one of many. This incredible idea challenges our perception of the universe and raises the question: what else is out there? The idea of nothingness before the huge explosion is speculative, not based on facts. Even if we removed all energy, particles, and radiation, the universe would still not be completely empty. Space is filled with dark matter, dark energy, and quantum fields, forces and energies that make up the fabric of everything. Even in empty space, if we imagine stripping away all these forces, space would still have new kinds of energy. This alone is puzzling for scientists, as it suggests that true nothingness may be impossible in our universe. Space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine a region with literally nothing in it. No particles, no energy, and no radiation, just quantum fields and constants. These fields would still exist, meaning that even this nothingness has properties. One such property is called zero-point energy, which is the lowest possible energy level of quantum fields. Even at this state, particles can suddenly appear and disappear, creating a strange form of activity even in what should be empty space. This challenges our idea of nothingness and suggests that even before the huge explosion, there could have been something that scientists are still trying to understand. One of the most fascinating ideas in modern science is the concept of eternal inflation. If inflation could create our universe, it could continue forever. Brian Cox talks about a vast, endless inflationary multiverse where universes are constantly being created and expanding. Imagine each huge explosion as a spark that starts a new universe, while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This idea of new universes giving birth to others is fascinating, offering the possibility of a fractal universe where each new universe creates its own enormous detonation. Each universe would be separate, not affected by others, since space is expanding so rapidly. For scientists, this idea is both exciting and unsettling because it suggests that the universe has no true beginning or end. Imagine our universe as just a small part of a much larger, infinite design, constantly expanding and creating new universes. What if, in reality, there is no beginning or end, but rather a continuous cycle of universes being born and dying? The way we think about nothing changes when we consider quantum field theory. According to this theory, the universe is not just a collection of matter floating in space. It is a complex network of energy fields that interact to create everything we see. These fields are like invisible oceans, with particles acting like waves or disturbances. Even when these fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear within these fields, borrowing energy and then returning it. This leads to the existence of virtual particles that exist only briefly before disappearing, leaving behind only a faint trace of their existence. The idea of virtual particles challenges the concept of total emptiness. Imagine a completely empty universe with no matter or energy. Would you truly have nothing? According to quantum field theory, no, you would still have fields that are constantly active, sometimes creating particles. This constant activity, even in what should be empty space, shows that the universe does not recognize our concept of nothing. These fields and forces continue to exist, filling space with hidden energy that prevents total emptiness. This raises an interesting question. If fields create particles and particles create matter, could the universe itself have emerged from this nothing filled with quantum fields? Dark energy is a mysterious force that is causing the universe to expand at an increasing rate. But did dark energy exist before the huge explosion? Some scientists believe that the dark energy we see today could be leftover energy from before our universe began. The properties of dark energy seem to point to a powerful force that could have existed in some form before the enormous detonation. Some theories suggest that dark energy, in a stronger form, could have driven the rapid expansion of the early universe. The fact that dark energy exists suggests that, even if all matter and radiation were removed from the universe, this force would continue to expand space. This idea raises a profound question. If dark energy existed before the huge explosion, could it have created the conditions that led to the formation of our universe? As we think about this possibility, we face the idea that there was never a genuine start, yet an everlasting grouping of universes being conceived, residing, and passing on. Cyclic cosmology brings up huge issues regarding time, suggesting that time probably isn't linear but repetitive. If this theory is valid, it means that what existed before the Big Bang was simply another version of the universe, one that ended and gave birth to our universe. For scientists, this idea offers a profound answer to the question of ultimate beginnings, suggesting that the universe has always existed in some form, beyond our traditional ideas of time and existence. Gravitational waves are another exciting concept that could help us understand what happened before the Big Bang. These waves, predicted by Einstein's theory of general relativity, were later detected, showing that our universe has deep, vibrating movements. Gravitational waves could, in theory, allow us to look further back in time than ever before, possibly even beyond the Big Bang. They could provide hints about what occurred before the universe came into being, assuming other forces or even different universes influenced how our own was formed. Scientists hope that gravitational waves will provide evidence from the time before the Big Bang, helping us break through the limitations of time and revealing a period that once seemed impossible to know. As we ponder what came before the Big Bang, it's clear that we stand on the edge of a scientific revolution. The mysteries remain, and what we know now may be only a fraction of what will be revealed as we continue to push the boundaries of human understanding. Yet the question still stands. What truly existed before everything? The answer may be stranger and more astonishing than we ever imagined. As we continue to explore the origins of the universe and the possibilities of what came before the Big Bang, we delve deeper into the realms of speculative science. While some ideas challenge the limits of our comprehension, others offer a fresh perspective on how the universe could have emerged. One thing remains clear. The nature of the universe is full of surprises, and the mysteries of its beginnings may be even more complex than we can imagine. One possible theory is that the universe may have undergone cycles of expansion and contraction, as suggested by the idea of the Big Bounce. In this hypothesis, the universe could eventually collapse in on itself, only to explode in another Big Bang, restarting the cycle. This cyclic model suggests that the universe may have no definite beginning or end, but instead continues in a loop of rebirths, where each new cycle is another version of the universe. As science advances, we may find answers to these profound questions. But for now, the mystery of what existed before the Big Bang continues to fascinate and inspire curiosity. As we delve further into the mysteries of what existed before the Big Bang, it's important to recognize that much of the exploration around this idea remains highly speculative. While we can observe the current structure of the universe and study its origins through the Big Bang, what truly happened before this event is still beyond our reach. This does not mean the search is futile. Rather, the very journey may reveal more about the fabric of reality than we could ever have imagined. One of the most profound aspects of cosmology is the role of time itself. As we understand it, the Big Bang marks the dawn of space and time. Thus, the very question of before becomes problematic. According to Einstein's theory of relativity, space and time are not separate entities but rather parts of a single, interconnected fabric known as spacetime. This means that asking what happened before the Big Bang may be meaningless, because time itself may not have existed before this event. If time is tied to the birth of the universe, then there may have been nothing before at all. The concept of before the Big Bang presents another paradox. In a universe where space and time were created in the same event, how can we apply our conventional understanding of past, present, and future? Could it be that time itself is cyclical, or that it is not bound to a linear progression? This leads us to the idea of time as a dimension that could stretch, contract, evolve, and loop without a fixed beginning. Ideas like these challenge our human intuition, reminding us that the universe operates according to laws that transcend our everyday experiences and perceptions. In the search for answers, one theory that has gained traction among physicists is the idea of a quantum fluctuation as the origin of the universe. In quantum mechanics, particles can spontaneously appear and disappear from seemingly nothing, an effect known as quantum fluctuations. Could the entire universe have emerged from such a fluctuation in a quantum field? This would mean that the universe, as we know it, could have emerged from a nothingness that was not truly nothing at all but rather a fluctuating quantum field. This view suggests that even before the Big Bang, there may have been a kind of quantum vacuum filled with potential energy, though not with matter in the form we recognize today. Yet, there are even more speculative ideas that stretch our understanding further. One hypothesis posits that our universe may have begun from a big bounce, a cyclic model where each Big Bang is a rebirth following the collapse of a previous universe. This model suggests that the universe undergoes an endless series of contractions and expansions, where it continually collapses under gravity and then explodes again, starting a new cycle of expansion. In this view, our current universe may have been preceded by another that collapsed into a singularity, only to give birth to the universe we observe today. This theory draws upon ideas from string theory and quantum gravity, but it also raises questions about what drives these cycles and how they could continue indefinitely. Interestingly, as our observational tools and technology improve, we may one day find indirect evidence that sheds light on these speculative ideas. Projects like the James Webb Space Telescope are providing astronomers with unprecedented views of the universe, capturing light from distant galaxies and revealing clues about the conditions of the early universe. By studying cosmic phenomena, such as cosmic microwave background radiation, believed to be the afterglow of the Big Bang, scientists hope to learn more about the earliest moments of the universe. In doing so, they may uncover evidence that helps us peer further into the origins of the universe and even explore the question of what came before. There is also the intriguing possibility that cutting-edge physics, still in its infancy, will eventually reveal deeper layers of understanding. Theoretical physicists are working on frameworks that aim to unify quantum mechanics and general relativity, an achievement that could allow us to understand conditions before the Big Bang. The theory of quantum gravity, for example, attempts to describe the behavior of spacetime at microscopic scales, where both quantum effects and gravity play a crucial role. If successful, these efforts could one day provide a complete picture of the universe's origins and allow us to explore its pre-Big Bang state. Some ideas even entertain the possibility that our universe may not be the only one, suggesting that we are merely one among an infinite number of universes in a greater multiverse. In this view, each universe would have its own set of physical laws, constants and properties. Our universe, with its particular arrangement of matter and energy, could simply be one of many in an endlessly expanding cosmic structure. This idea also raises the possibility of parallel universes, where events unfold differently than they do in our own universe. The concept of the multiverse could reshape our understanding of the Big Bang, suggesting that our universe is just one of countless others that have emerged through similar or vastly different processes. Despite the enormous challenges of answering what existed before the Big Bang, the pursuit of knowledge continues to expand the horizon of human understanding. As scientists continue to explore quantum mechanics, cosmology, and the fundamental forces of nature, the answers to these questions may eventually emerge. Whether we find evidence of a pre-Big Bang universe, uncover new insights into the nature of reality, or stumble upon entirely new ideas that challenge our comprehension, one thing is clear. The mysteries of the universe are vast, and we have only just begun to scratch the surface.